Number 31, graph the given constraints, which are right here, and find the ordered pairs that produce the maximum and minimum values of the given objective function. So the ordered pairs are going to be the corners of this feasible region. So these are the three functions that I'm graphing. These are the three constraints. I'll do the first one in red. So the y-intercept is 2. We're going down 1, right 4, down 1, right 4. And we're going to make that a dashed line because it is just y is less than, not less than or equal to. And we're going to shade that one below the red line. Next equation. Y-intercept is -5. Right there. Up 3, right 2. Up 3, right 2. This is a solid line. Maybe it's straight, but not this one. And we're going to shade above the line because it's where y is greater than or equal to. So right now I'm just going to shade above the line where the red is. Remember when we have these systems of inequalities, it's just where the plat is, where both colors are all colors in this case turn up, because now we're looking for not just where red and black is, but where blue happens. So y-intercept of this other function is +2. But we're going to go down 2, right 1, down 2, right 1. And it's going to be a solid line. And we are shading where y is greater than or equal to the line, or so above the line. And so this right here is my feasible region. And so I'm going to look at what the coordinates of the corners are of that. The corners occur at 0, 0, 2, and at 4, 1, and at 2, -2. So now we plug that into the objective function. So we're going to go 2 times 0 minus 5 times 2. You get -10. And let's try the other ones to compare -10 to where they align with this. Minus 5 times 1. So you get 3. And then here, 2 times 2 minus 5 times -2, and you get 14. So what produces the maximum? It's the point 2, -2. What produces the minimum? It's the point, well, -10 is the minimum value given, so that's 0, 2. Solve the systems of equations. Remember, our goal is to combine. If we number these equations, we're going to try to eliminate one of the variables using 2 of the equations, and then eliminate the same variable using the other equation that we didn't use, and then one of the ones that we did do. And sometimes we have to multiply here, but what you're going to look for is a variable that has a set of opposites. And so z here I can have a -z and a positive z. So 1 and 2 could combine. Those two equations could combine to have no z's in them. And then I could use 2 and 3. And the z's will cancel out here when I combine. So let's go 1 and 2. So it's kind of like a new hybrid 1 and 2 equation. And I get 3x plus 4y. Again, the z's canceled out, equals -5. So that's using equations 1 and 2. Now I have to use equation number 3. I'm going to do it with equation number 2. You're going to have to repeat one of the other 2 equations, either 1 or 2. It makes the most sense to use equation number 2, so the z's cancel out very easily. So here I get 4x plus 2y, z's cancel out, equals 0. So now, folks, I have these two new equations that really encompass the 3 equations with 3 variables. It's just that now I have only 2 equations that encompass the 3 equations, and they only have 2 variables. So now we can use our skills to put these 2 equations together and figure out how to get either x or y. So I'm just rewriting my two equations. And I notice here, shoot, I don't have opposite. But if I multiply the bottom equation by -2, I would get a -4y. When I combine it with the top equation. So I get 3x plus 4y equals -5, and -8x minus 4y equals 0. So I get -5x, this cancels out, equals -5. So I now know that x equals 1. Well, I can go back to one of these two original equations if I know that x is 1 and there's only the only other variable in there is y. So I can figure out what y is. So 4, I'm going to use the bottom one, 4 times 1 plus 2 times y equals 0. So I get 4 plus 2y equals 0. So I get 2y equals -4, so I know that y equals -2. So now I need to find z. Well, now I need to use an equation that has x, y, and z. So you have to go back to the originals now over here. And I'm going to use, I don't know, equation number 2 because there's no negatives. And I don't know, I just want to do it. So 1 plus 3 times -2 plus z equals -2. So when I simplify the left side, I get -5 plus z equals 2. Add 5, z equals, oh, did I copy something wrong? I'm getting 7. An answer key that I have off to the side here says that it's 3. Let's see, 1, -2. Oh, did I? I think that's right. Oh, I made a mistake. This is why you show your work, folks. I made a copying mistake, yeah. Part of it was a squeeze for time. That's a -2, and then I didn't bring down a -2. I brought down a +2. So let me put a -2 there now. -2 plus 5 is 3. And then you can write this as an x, y, z coordinate pair. So x is 1, y is -2, z is 3. There's your solution. That was fun, huh? Number 33, what is the vertex of this function? Remember, we do the opposite of this, OPP, and then whatever this is. So the opposite of that is 2, and then bring the 7 down. Find the vertex by completing the square. Let's, you know what, folks, this is in standard form, so that's kind of silly to do. Let's just do the x value of a vertex is the opposite of b over 2a, and then plug in that new x into the function. So the opposite of b is 16. 2 divided by a is 2 times, or 2 times a is 2 times 1. So we get 8. So now let's plug in 8 into this function. So we get 8 squared minus 16 times 8 plus 25 equals some number, and then we put that number in with a coordinate pair, or with our in our coordinate pair with the 8 for x. And so when you do that, you get y is, I think, -39. So there is the vertex of this function, 8, comma, -39. Cool beans. Write the equation in standard form. So that means we need to have like an x squared. Remember, standard form looks like this for a quadratic function. So I need to square this x plus 1. And so that's going to give me x squared plus x plus x plus 1, which gives me x squared plus 2x plus 1. Then I distribute, and then I'll subtract 5. So I get y equals 2x squared plus 4x plus 2 minus 5, which equals y equals 2x squared plus 4x. 2 minus 5 is negative 3. So to talk through that process, to break it down, and this is something, what you can't do, folks, here is distribute this 2 into the parentheses. That's a When we're simplifying things, we have to do what's in the parentheses first, which you can't take x plus 1. But then you have to do the exponent. And x plus 1 quantity squared means x plus 1 times x plus 1. So we need to take care of the exponent first. Then I multiplied this 2 into the simplified version of x plus 1 squared, and then we combine like terms. So you gotta, this is not solving an equation, this is simplifying an equation. So we have to follow our order of operations.